Sir, are you ready with your presentation?
Just a second. Yeah. First, I would like to thank the Seventh International New York Academic Research Congress for giving me opportunity to present the work. The title of my presentation is Removal of Metal Salts from Activated Carbon Derived from Acacia Erioloba Seed Pods by Physical Activation. The authors, my student Eric, myself, supervisor, co-supervisor David Nanhapo, and Danny Likius, my colleague. The outline is as follows: introduction, motivation of study, objectives, literature review, comparison of activation method, methodology, results, and discussion, conclusion, acknowledgement, and references. So the introduction is as follows. So adsorption, it is by activated carbon is widely used, well-known effective method for water treatment. And this adsorption process by activated carbon has many advantages comparing to the other methods. So advantages mostly include less land area requirement for AC adsorption process. This is not affected by toxic chemicals. So AC is capable of reducing high concentration of uh, metal contaminants for from water. So this is very easily available, activated carbon, cheap and high degree of purification. And the main property is high surface area, which can absorb any contaminants. So motivation of study, how did we get the motivation to study this research project? The activated carbon samples that are used in the country, they are imported from foreign countries here in Namibia, that is from South Africa, and it is very expensive to acquire that. So hence, acacia seed pods, these are readily available. Previously, they have reported acacia activated carbon from acacia seed pods using H2SO4 as impregnating reagent. This was reported by me and my student and co-workers. So improving the drinking water quality, it will provide significant benefits, that is to the health of the people. So here in this current study, Namibians, by creating a novel process of water treatment that is very cheap and eco-friendly process. So the chemical activation of AC, it is considered more advantageous compared to the physical activation, hence consumes less power, and it produces high yields and high porous AC. The more the surface area, the better the absorption capacity of contaminants will be on the AC. We further investigate a different approach, which will give better results. So objectives are as follows here. That is preparing a chemically AC from seed pods using physical method and H3PO4. That is phosphoric acid for impregnation and use for adsorption of metals, that is contaminants from wastewater. So the specific aims that include, it will determine the percentage yield, moisture, and ash content to characterize the prepared AC by scanning electron microscope and FTR. So literature review here, it is highly porous material, high adsorption capacity it has, depending on the structure that will remove the color and various impurities from wastewater. So this can be prepared in two ways, either by physical or the chemical method. And Acacia reliba, this is known as giraffe thorn or camel thorn, mistranslation from the African name, camel doring, meaning giraffe thorn, all these things. So it is highly dominant tree, highly recognizable on the Kalahari Plains in Angola, Botswana, Mozambique, Namibia, South Africa, Zimbabwe, and Zambia. It is found mostly in Africa, you can say in general. So this genus has been used in Namibia and Namibian companies in the production of charcoal, and has been used for the purification of water. So acacia seed pods produce high quality charcoal, and slow burning produces little ash. So low ash content is there, creates high porous structure of the AC, hence increasing the adsorption capacity. So comparison of the activation methods, physical and chemical activation methods, both. So physical activation method does not use chemical impregnation, directly taking the material and heating in the furnace for specified temperatures, can be 500, 600, 700, depending on which will give the better result. Chemical activation, this will use the chemical impregnating reagents, mostly the dehydrating reagents they are using, H2SO4, HNO3, HCl, zinc chloride, etc. Bases also they will also use sodium hydroxide, sodium carbonate, potassium hydroxide, etc. Higher activation temperatures, longer reaction time for the physical activation, lower activation temperature, and less time for chemical activation. So here the methodology used for preparing the AC, that is by the physical method, was first these material acacia seed pods were collected within the University of Namibia, that is from the Faculty of Science backside, washed, and it is dried, sieved these pods to 50 and 100 microns, and then it is paralyzed in oven 500 degrees centigrade for 1 hour in muffle furnace. And then these samples are dried in 105, at 105 degrees centigrade for 3 hours. Then by another method we have adopted, that is the chemical activation method. Here again, same, the collection process is same. 20 gram of AC samples were impregnated with, that is 150 ml, 10% H3PO4 phosphoric acid, good dehydrating agent, in 500 ml flask. Then it is washed, filtered with hot water, and neutralized pH. Why we are washing with the hot water is so that the pH will be neutralized, no doubt, but it will remove the impurities very fast compared to the normal water washing, which will take more time. That is the difference between washing with the warm water and the normal water. Then it is paralyzed in furnace 500 degrees centigrade for 1 hour. Then the samples are washed with hot water and then with 0.1 m HCl in order to remove the impurities, the ashes which are formed. This is the last step, that is the purification. Then the samples are dried in oven 105 degrees centigrade for 3 hours. Then heavy metals, how heavy metals contaminants tap water samples are treated here. 0.5 gram of prepared AC is taken, and that is 50 and 100 microns. Then it is stirred at room temperature for 2.5 hours. Then gravity filtration is done with the Wattman filter paper, and the observed color changes you will see, and these samples will be analyzed by UV visible spectrophotometer. Results and discussion. The prepared properties of the prepared AC. We have the ash percentage, moisture yield of the prepared AC of the both sample AC1 and AC2 here, and they have percentage around, it is going above 20 for almost, and the third one yield is around 30%. Then UV analysis, iron contaminated water with AC3, H3PO4 impregnated. We can see A, B, C, all the samples have been done. These for the iron, different concentrations they are. We have taken from the 1.5 to 2.53 concentrations. And with this, we can say that from 500, after 550, the metals had been absorbed. The straight line which is coming, it has given a good result for the I sample. Then UV analysis for copper, contaminated by physical method. This is here, physical method also gave good result, not as compared to the H3PO4. Maybe here you can see, then once it has been degraded, absorbed by on 400, but it is not completely, copper had not been removed from the solution. This could be due to maybe the pores of the activated carbon prepared by this method, wide pores are not being observed. So chemical treatment is more valuable than the physical method. Maybe we have to increase the temperature also in the physical method. Then chromium also has been tested with the H3PO4, which was not much effective for removing chromium by this method. So SEM analysis we have done, SEM characterization. Where is my present? Sorry, something went. Oh, some wrong has happened.
So you can close and re-share your screen again.
Yeah, I'm doing
Stop
that.
sharing your screen and you can continue again.
Now is it coming?
So it's showing the slide number 15,
Yeah, but here it's not
the previous.
visible. It's coming for you visible?
Yes, sir. Yes,
Oh,
sir.
okay,
I can
fine.
see slide number 15.
Okay, thank you. Right. So
Okay, sir.
same images of
Continue.
the prepared AC from H3PO4. The external surface it is showing and the internal image also. The external, that is the morphology, we will know what is the structure of the prepared AC from H3PO4. It might be rock solid, that is square or rectangle like that. And the B, the internal image, one sample they will detect and they will see whether it is porosity is there inside, what size of the pores it is, whether it is nano. Then the physical method also we have seen for this. Yeah, this is the extended image of the H3PO4 and small samples they have taken, and same property it is giving, nanostructures being formed in the B1. Then FTR studies we have seen for the prepared AC from the physical method, and we can see at the 3400 hydroxy groups are formed. And same being observed with the H3PO4 also when FTR studies were there at 34 to 3500, OH is more prevalent. In conclusion, activated carbon prepared from Acacia Erioloba seed pods by physical activation, that is using H3PO4, which is an activating agent. This is characterized and used for the treatment of the water sample. So 80% of the organic contaminants, they were absorbed, treated, and 50, 100, and 200 microns were also tested. Density, bulk density, high compressibility was formed. Lower solute concentrations, particle sizes for longer contact times, lower adsorbent doses, these were found to enhance the solute removal. So other researchers' findings on AC have showed that enhancing AC with different metals greatly enhances absorption function of heavy metals removal by AC from wastewater. So this is used as an adsorbent and substitute for activated carbon, and it has been established that Acacia Erioloba seed pods could be used for commercial purposes. Acknowledgement, finally, I would like to acknowledge the New York Science Conference organizers for giving opportunity to present our work. I would also like to acknowledge School of Science, Department of Physics, Chemistry and Material Science, University of Namibia, particularly for providing the necessary equipment and materials needed for this research project. These are the references. Thank you.
Thank you so much, Ateeq sir. Is there any questions for Ateeq sir? Is there any questions? Okay, I think there's no questions, sir. Thank you so much for the presentation.
Thank you. Thank you.
Okay, sir. Moving ahead, now I would like to invite Purnima Devi